just so people can see it later. So let me look at question number 4. And then I will do the other ones, number 9 and number 2 and 3. So question number 4 looks like this one. Is this the one you're talking about, Sadie? Hold on. That one?
Yeah, that was the second one, but that's not the first one I was telling you about. I
Okay.
think it's question 3.
I think it is too. I think it's this one.
Yes, that and question 4.
Okay, so let's look at 2. We'll do 2, 3, 4, and then I think it was 9 was the other one. I think that's the one you asked for. I'm gonna make sure. Yeah, okay. So let's look at 2 first, and 2 I'm going to do just using the annotation. So this kind of goes off of what you're supposed to do with the mean value theorem. So if you look at this, and we look at the secant line between 1 f of 1 and 5 f of 5 would be that line right there. Okay, so that's the secant line. That's this part right here that we're being asked to kind of look at. And we're supposed to figure out when we're dealing with parallel values. So if I were to change, I'll change the color, but if I start drawing the tangent lines in red at each of these points, I might have one tangent line that kind of looks like that at R. T is a little bit trickier. I think that it would probably be something along those lines, although you might have some questions about that, but I don't think we have to worry about that one too much because clearly it's not parallel to the green one. Up here at U, if you drew a tangent line, it might look something like that. And over here at W, if you drew a tangent line, it might look something like this. So clearly, that's the one that is parallel to the green one. And that's the idea behind the mean value theorem. The mean value theorem says that the secant line, which is the green one, is equal to the derivative lines, which are the red ones, somewhere on there. It doesn't have to always equal, but it has to equal it somewhere on there because that function is differentiable and continuous on the interval. Any question on that? Okay. I'm going to clear these annotations so that I can continue to draw on other things. Otherwise, it just gets confused when it switched things. So stop me and if you still need me to explain that a little further. Your silence means that I'm going to clear it. Okay. Come on. Okay. So question number 3 looks like this. And I think this is harder than anything that I would ask you, that I did ask you. Not that I would ask you, but that I did ask you. So so if we get done with this and you're like, I didn't quite understand that, maybe I'd say go back and watch it again, or stop me if you don't understand something that I do. But the idea behind this is somewhere f prime of c is equal to f of b minus f of a divided by b minus a. Now that's from the mean value theorem. That's really what the mean value theorem says. So if it's a free response question, you're going to set that up. If this happens to be a multiple choice, so you have to kind of come up with the value on it. And I agree that this is not the easiest one to, the computations on this are somewhat challenging. So f prime of x on this problem is the derivative of sine is cosine. Leave the x over 2 alone, but then we have to differentiate the x over 2 into 1/2 because that's the derivative of x over 2. That's the chain rule. So that's the chain rule. So that's that. Now, what we need to figure out is when is 1/2 cosine x equal to the sine of 3 pi over 2 divided by 2 minus the sine of pi over 2 divided by 2 divided by 3 pi over 2 minus pi over 2. So that's what we have to figure out. Now, this is x over 2. So that the hardest thing is to deal, like we'll deal with the left side in a second, but we got to kind of deal with the right side. One of the things that you could do, so if you, let's say you were in the heat of a test and you were like, okay, well, I know that I have this, and you're like, I know that the bottom separates into pi, but the top, I don't know what the top is. And you were like, well, I don't know what the top is, but then you look over here at these answers. Based on those answers, knowing that the cosine graph, the normal cosine graph looks like this, should kind of give you a clue that if I were going to evaluate this, this better be 0. Because when I'm trying to find out this value x is one of these angles down here, I can't have this be anything other than 0 because I'm going to divide by pi anyway, because I need this whole thing here to be 0. Now, that would be the way I would fudge that in there. Now, if you were like, well, how does that work? Let me show you how that works, okay? So the sine of 3 pi over 2 divided by 2 is the same thing as the sine of 3 pi over 4, if I just do the calculations on it, okay? If I do the arithmetic on it, that's what that is. The sine of pi over 2 divided by 2 is the same thing as the sine of pi over 4. Okay. So we're subtracting these two values. One of the things you got to kind of remember is that
Mr. Alquist, wouldn't it be 6 pi over 3?
no, because you multiply by the reciprocal. So since you're dividing by 2, you multiply by 1/2.
Oh.
So like 3 pi over 2 divided by 2 is the same thing as 3 pi over 2 times 1/2, because this is kind of like that, which is 3 pi over 4.
See, I did it the other way. I thought it was like 3 pi over 2 times
Yeah.
2 over 1.
Yeah, and it's times 1 over 2.
Okay. Sorry about that.
No, that's a good question. I'm going to erase this so I don't run out of all the room that I'm going to use. So now, if I look at the sine curve looks like this, roughly, where this is pi. If you look at what I'm trying to evaluate, I'm trying to evaluate pi over 4 and another value over here, 3 pi over 4. Because remember, the pi is also 4 pi over 4. Okay, so that's the same value. So that's why when we go up to here, that's why that top number is 0. Okay, so now here's what you have. Okay, let me show you what you have now. What we have at this point is we have 1/2 cosine x over 2 has to equal 0. That's what we're trying to solve. We need to solve that value. Okay? So here's the way I would solve it. what I'm really looking at is the cosine x over 2 has to equal 0 because 1/2 can't equal 0. So that's what I have to solve. So here's the way I solve it. Here's my thought process on how I would go about solving this. I would go about solving this thinking that, okay, my cosine graph looks like this. And right there is pi over 2. So the cosine of pi over 2 is equal to 0. Because that's what the cosine graph looks like. What that means is that means x has got to equal pi. And that's the answer. And that's how I would solve that problem. That's a really hard problem. It's harder than anything. The mean value theorem is tested for you on the exam, but this particular mean value theorem, the computations involved with it are harder than what you have. If you look back at the progress check 1, we had that mean value theorem is more similar to what I put on the exam, but I didn't have another one to pull from it, so I did that. So this concept of the mean value theorem, which is this concept right here, that is tested on the exam, but not at the level that this particular one was. Okay. Can I move on to the next problem? Now, AP might test you on that mean value theorem, depending on the year, depending on where they put the mean value theorem, but I can't predict that as easily. Okay, question number 4. So question number 4 looks like this. And oh, I didn't want to do that. Question number 4, I'm going to do something. I'm going to see if I can shrink this down and still see it. There. Okay. So here's the way I'm going to deal with question number 4. I'm going to kind of extract some information. The first thing that I'm given is I'm given g prime of x is greater than 0, which is positive, which means g of x needs to be doing what? What would you say?
Increasing.
Exactly. Okay. The second thing they give us is g double prime of x has to be greater than 0, which again, that's positive. Somebody other than Sadie, tell me what that means for g of x.
It needs to be above 0 on the y.
Well, that's what g double prime, but what is
Oh,
g
G.
double prime being positive? What does that mean for g?
Oh, sorry.
According to the chart.
Wouldn't
Huh?
it be positive? Like
Increasing.
increasing. My bad. Concave up.
Concave up.
That's what I meant.
So we know, because then we get asked a question about, because the question really says, what is g of 6 if g of 4 is equal to 12 and g of 5 is equal to 18. But we know this is what our graph looks like. Okay, so that's the calculus. What I boxed in is the calculus. And really what the calculus is saying is we have a graph that looks like this, a graph that's increasing and concave up. Okay, that's what it has to look like on some level. Now, here's what you need to kind of figure out is you need to go, okay, well, if g of 4 is equal to 12 and g of 5 is equal to 18, and we're trying to find what g of 6 is, notice that this change is up 6, right? So that means if g was linear, then G of 6 would be 18 plus 6 more, or 24. But it's not linear. It's actually concave up, which means it needs to grow more than 24. Because G is concave up and increasing, G of 6 must be more than 24 because G is increasing and concave up. So that's kind of the idea on how you come up with that problem. Is you got to extract that information that I put in the box, which really comes from the chart, and then get an idea of what this thing is doing and what G of 6 would have to do, and it would have to go up more, which is why 27 is. There's only one answer that they have that works out that way. Now, if you interpret what went the G prime greater than 0, G double prime greater than 0 incorrectly on the chart, then you might not be able to get 27, but that's how you would get that problem. Okay, so that's what I would do with that problem. Any questions on that before I move on to the last one that you wanted? I can do more if you need more. So let's look at number 9. Okay, so number 9 says you got these graphs, and we did problems kind of similar to this. When you look back at the delta math assignment, there was a delta math assignment where you had to identify F prime, and F double prime. So if you're like, wow, I could use more help on this, this is the one that I would go to it and look at it. But a couple things that I would highlight for you is I would highlight the following. Oh, I didn't want to do that. Hold on. So a couple things I'd want to highlight that I want you to kind of realize is if G has a relative maximum, G prime is going from positive values to negative values. If G has a relative minimum, G prime is going from negative to positive. So that's a really important piece. That comes right from the chart. Now, the other thing that comes from the chart is if G prime has a relative maximum, G double prime is going to go from positive to negative. And G is going to go from concave up to concave down. That comes from the chart also. Okay, and the last thing is if G prime has a relative minimum, and remember, if it's a relative minimum, G prime would be going from decreasing to increasing. And then G double prime is going from negative to positive, and G is going from concave down to concave up. So from these things, from these 4 things, this is essentially another way of writing the chart, maybe being a little bit more direct when you have stuff like this going on. So when I'm looking at this and I'm trying to determine which one is G, which one is G prime, which one is G double prime, some of it is going to have to go through a trial and error. Okay, some of it's going to have to go through some trial and error, like you just pick one to be G prime and then say, well, which one would have to be G if that one's G prime, and so on. If you had this kind of problem on the exam. So if I look for it, notice that this lighter colored one right here, that's a relative maximum right there. And notice that, so that's number 2, has a relative maximum right there. And that at that place, let me see if I can annotate it the best. So I'm kind of looking, if I'm looking at things, I'm going to look kind of right. Hold on a second, let me get the right thing here. I'm going to look right here. That's a really key component. I might look right here. And notice when I look right here, what's happening there. And then I also might look right here. Notice what's happening right there. And then I might look right here, and that might help me as well. So when I'm looking at this, I'm kind of looking at significant things that are happening in the graphs and significant X values. Notice that on this first one, this graph right here, this solid colored graph is going from positive values to negative values. So if a graph is going from positive values to negative values, what you should remember is anytime it's going from positive to negative, something has a relative maximum. And notice this one right here has a relative, 2 has a relative maximum right there. So when I'm working through this, that's kind of the ideas that I'm going to go with. I'm going to show you the answer so you can see. So the third one is F, the second one is F prime, and the first one is F double prime. Now, you have to kind of go through and kind of look at what's a relative maximum of what, and kind of go through, notice that the third one has a relative minimum right there. So that one right there, that third one has a relative minimum right there, goes from decreasing to increasing, which means you have to one of the graphs has to be going from negative to positive there. Would have to be going from negative to positive right there. And that's how you maybe could line them up. And it probably has to do with the process of elimination. Any questions on that? Okay, so that's how I would do that problem. But a lot of that comes from this whole thing here, which is just another way of writing down the chart. It's another way of kind of copying some information down from the chart. That's why that chart is so vital. Okay. So if I wrote the right answer on here, let's see. F is 3, F prime is 2, F double prime is 1. So so this is F, this is F. Oh, my mouse is not working today. And this is F double prime. So I think that's what it says on here. Come on, there we go. Yeah. So there you go. Okay. What else can I do? Anything?
I'm good. So I'm gonna
Are
go.
great, Sadie. You are not just good.
What about me?
I know I actually did pretty well these past 2 times, which I was surprised about.
I'm not surprised.
Sadie
But-
takes good notes.
I take good notes, you're right.
Having good notes and really understanding the chart is like a lot of the battle on this one, honestly.
Wait, we're allowed to use our notes on tests? I'm just kidding. All
On
right.
the actual AP exam, no, because you'll be in person.
Yeah,
That's
well,
so unfair. I will
to
forever.
be honest, I don't think I want to take it.
Yeah, neither do I. Now
Yes,
that I
you
know,
are.
like,
But I feel like you're gonna make me. So
Well, here's the thing. Is by the time we get to there, I
We'll
feel
be
pretty strongly that I'll have you ready to do it without notes.
okay, by the time we get there, we're probably what, 30, 40 days into hybrid.
Yep.
assuming all of us are doing hybrid.
Assuming, yeah.
So here's the thing is I look at it this way. I kind of go, what's the part of me kind of looks at it and say, what's the harm? Like if I think I'm going to have you ready and I get you ready and then I say, okay, well, what happens if you don't do well on the AP exam? Like honestly, what happens? Nothing. Now let's go on to the other side and let's say you do well on the AP exam and you get a 4 or a 5 and suddenly you actually generate 4 or 5 credits at whatever school you're going to go to, and suddenly a credit at like, well, I can tell you credits at one of my kids goes to Nebraska, and each credit is $800.
Jeez.
Let's say that he gets a 5 on or a 4, and at Nebraska you could have gotten a 3 and gotten a 4 credit calculus course. That's $2,400 in tuition. You can't make that much proportionally for 3 hours of work in a summer job. You don't get paid enough. So why wouldn't you take it? That's what I would say.
It's just gonna be hard because we're gonna come off of taking every test with notes, so we're gonna be dependent on notes.
I mean, because if you say, well, it's going to be hard, so I'm not going to do it, you should never play Hopkins in basketball. You should, when section comes along, St. Louis Park should just say, screw it, we're in a higher section, we're not going to play. And we're not going to show up. Not only are we not going to play, we are actually not going to get a bus. We're not going to show up. We're not going to step on the court because we know we're going to lose. Well, yeah, that's the
All right, I'm gonna head out.
And don't do that. I think you have a chance.
I'll think about it.
Okay.
Or I'll change your course back to.
No, I was never contemplating. I'm just annoyed.
You
that
just
we're-
said you. Okay, whatever.
No,
But
Sadie, don't put Sadie.
I don't want to
in
get
your
into it with you,
category,
Sadie,
Jonah.
but that's BS. Anyway,
Okay,
all
All right.
right. Have a good day, Mr. Alquist.
see
Have
you
a good
guys.
Bye.
right.
Thank you, Mr. Alquist.
See you, Johnny.
Bye.
Ilhan, did that make sense?
Yeah, that made sense.
Perfect.
Thank
Okay.
you.
You got it.